In this video, we will discuss two devices that are used to measure the pressure of gases, namely the barometer and the manometer. The barometer is an instrument used to measure atmospheric pressure. The diagram shows the parts of a simple mercury barometer. It consists of an evacuated thick-walled glass tube with the open end of the tube submerged in a pool of mercury. The space at the steel end of the tube is a vacuum. Hence, there is no pressure exerted on the mercury column at the top of the tube. The atmospheric pressure pushes down on the pool of mercury and forces the mercury up the tube. The height of the column of mercury level above the surface of the mercury in the dish is measured, and this corresponds to the atmospheric pressure. The atmospheric pressure at sea level is 1.01 times 10 to the power 5 Pascal. What is the length of mercury column that the atmospheric pressure can support? Can you try this? We know that pressure of liquids along the same horizontal line is equal. Hence, pressure at A is equals to pressure at B because they are along the same horizontal line. Pressure at A is also equals to the atmospheric pressure, which is known to be 1.01 times 10 to the power 5 Pascal. And pressure at B is the pressure due to the mercury column given by ρ, density of mercury, G, gravitational field strength, and H, height of the mercury column. Now, will you be able to continue the working to find that the atmospheric pressure at sea level can support a mercury column of up to 76 cm? Like previously discussed under liquid pressure, this height of mercury column is independent of the shape or cross-sectional area of the tube. Unlike the barometer, which is an instrument primarily used to measure atmospheric pressure, the manometer is used to measure differences in the pressure of gases. The manometer consists of a U-shaped tube partially filled with a liquid, usually mercury, oil, or water. The diagram shows the manometer when it is not connected to a gas supply. Atmospheric pressure acts on both surfaces of the liquid in both arms of the manometer. Hence, you see that the liquid level is the same in both arms of the manometer. The diagram shows the manometer with one end connected to a gas supply. The difference in height of the liquid levels in the two arms of the U-tube indicates the pressure difference between the gas in the two arms of the manometer. At the left arm, the gas exerts a pressure of P gas on the surface of the liquid. On the right arm, the pressure exerted on the surface of the liquid is atmospheric pressure. Since the atmospheric pressure is larger than the gas pressure, it pushes the liquid level downwards on the right, and the liquid flows upward in the left arm of the manometer to equalize the gas pressure. If we were to examine the situation, the pressure at this point, let me call this point A, must be equal to the pressure at this point, let me call this point B, because they are on the same horizontal line. Hence, we can easily form an equation. P gas plus pressure due to the mercury column is equal to atmospheric pressure. In this new diagram, We can see that the manometer is connected to another gas supply with a higher gas pressure than the atmospheric pressure. Hence, the gas pressure exerts a force on the liquid surface to push the liquid level downwards on the left, and the liquid flows upwards in the right arm of the manometer to equalize the gas pressure. If we like to examine the situation further, we can easily form an equation. Gas pressure P gas is equals to the atmospheric pressure plus the pressure due to the mercury column.